Yeah, thank you. I'll be talking about large language models, or LLMs, in chemistry. And so to start, I'm going to talk about chemists first. Basically, you have two kinds of them. You have experimental chemists. And just to describe very quickly, if there's any chemists here, please forgive me. What they do is they design molecules, materials to solve problems, then they plan how to make them. They go in the lab, they make them, and then they analyze all of this to learn some chemistry to find out if they actually did what they wanted to do and if they're actually solving the problem. This is a very expensive and this is a process that takes a long time. And then on the other hand, you have the computational chemists, which, to be very simplistic, they just build tools to help the chemist, the experimental chemist. The problem is that this connection is not always actually achieved. These tools that computational chemists build are not always transferred into the experimental chemist workflow, so that is a problem we want to tackle. Now, on the other hand, the other part of my talk is going to be LLMs. So you know large language models, you know things like ChatGPT or Claude or Mistral AI. This is very popular, so I'm not really going to introduce what they are. But the important thing for this is that they have shown some nice capabilities. So for instance, people have said that they sort of reason to some extent. They can use tools, they show some features of general intelligence. I'm not going to go deep into that discussion, but let's say in the surface you can see some properties. Now, one of the cool examples that people use to show that GPT-4, for instance, displays some sort of reasoning is that it could draw a nice unicorn. As you see, it's very nice and artistic. And so if GPT-4 can draw a unicorn, you might think, okay, I clearly can do chemistry. And the answer is no, they cannot really. They will just hallucinate whatever whenever you ask them something, and so this is completely useless for the chemist's workflow. However, how about we use LLMs as an interface to build these tools? And so the point here would be, okay, if we kind of bridge the computational chemist with the experimental chemist through an LLM, then we will gain the accessibility of LLMs because they're super easy to use. Everybody just talks to them, and that's it. You get whatever you want from them. And then on the other hand, you got the accuracy from the chemistry tools. So you kind of have both there. Now, the point of using LLMs with tools is the following. If I ask you this question, can you answer? Unless you're Swiss and very much into politics, then yes, but probably not. But then if you ask GPT-4, it will definitely make something up. But if you include Wikipedia and you give it access to it, then it will tell you, okay, now Viola Amherd is the president of Switzerland this year. So that's kind of the point. We kind of augment language models with tools, in this case, like databases or just wikis, so they can know better about the world. So here I introduce ChemCrow. ChemCrow is basically GPT-4, where we give access to some chemistry tools that we curated and wrapped for it. And so just to give you a short introduction, in GPT-4, we give it some molecular tools. So for instance, we give some tools to calculate molecular properties or name converters, databases, and so on. So now it can manipulate molecules and work with that. It also has some access to reaction tools. So for instance, it can do retrosynthesis, so plan how to make something. But then also it has access to a robot, which is a pretty cool thing. So now GPT-4 actually has hands and can synthesize stuff. And we also have some general tools on, for instance, a Python code interpreter. It can do literature QA, do some search in Google and stuff like that. And finally, some safety stuff, which basically prevents GPT-4 or ChemCrow to suggest some, let's say, stupid stuff to do to the users. We don't want people getting hurt. Chemistry can be dangerous. So this is kind of how it works. I hope you can see, but anyway. So basically, you have ChemCrow on the one side, you have the human, or whatever, in that case, me, telling it what to do. And so what you tell it to do is simply, in this case, plan and execute the synthesis of an insect repellent. And so the way it would work is basically, ChemCrow would say, I need to know which insect repellent to synthesize. So the point of this is it will try to plan what to do to solve that task, given the tools that it has. So it will say this, okay, I need to know, first of all, what to make. And then, okay, I will do a literature search to find a common insect repellent. And so again, this is a language model talking, kind of planning what it's going to do. Then, okay, we'll find this tool, it will get back an answer, and so it will next go ahead and select one of these. So it selected DEET, but then it has to get the smiles of DEET, like a molecular representation for it. So it gets it. Now it goes ahead and plans how to actually make that, and so uses a tool that can actually give you a reasonable kind of like recipe how to make that molecule. And then finally, okay, now that I have a synthesis plan for it, I'm going to execute that synthesis. It goes in this tool that gives it access to an API to the robotic platform that we have in IBM Zurich. And 3 hours later, we have this nice message telling us that we actually got that. And you can, well, we could check that that is the case. And so, yeah, just to conclude, with ChemCro, we can do some chemical synthesis, automate it to some extent. We can do some sort of materials design up to some point again, and some chemical Q&A, which is pretty useful. And we hope that with this, we can accelerate discovery in chemistry. So thank you very much, everybody. There's a demo there if you want to try it.